Okay, so now we're finally getting to the punchline of all this factoring and stuff we've been doing. These are really, again, quadratic equations, the ones you've noticed we focused on the most, solving those. So just to review here, again, standard form of a quadratic equation. So we know what a quadratic function is, right? Ones like this we've been talking about where, it's y equals 3x squared plus 4x plus 2 or whatever. You guys have had to factor them. So this time, we're going to say a is definitely not 0, right? Because otherwise that just makes it a straight line. It's called the standard form of the quadratic function. And again, it's an equation. We throw in the y there. Examples here, y equals 3x squared, y equals x squared plus 9, y equals x squared minus x minus 2. The simplest quadratic functions are x squared, y equals x squared, or f of x equals x squared. It's called the quadratic parent function. And this is not in your vocab. But these are things that I just wanted you to know what that looks like. And that's a graph that looks like this. So notice a nice curved graph. It's not straight lines for sure. The graph of a quadratic function is a U-shape called a parabola. The parabola with the equation y equals x squared is shown to the right. Again, that's the quadratic parent function. You can fold a parabola so the two sides match exactly. This property is called symmetry. So this half equals this half. The fold line that divides the parabola into two matching halves is called the axis of symmetry. So important information as we move forward with this, just so you understand what it is that we're really looking at. So some examples. Now again, we've seen these, right? You know how to factor all things like this. If I were to graph it, y equals 2x squared plus 2 looks like this. I want you to notice, by the way, how it crosses the x-axis here and here. Those are called the zeros. So here's another one. Y equals 2x squared plus 4x. And notice again here, it crosses here and here. Those are called the zeros. Notice how similar this looks to y equals x squared. So if you were to compare the graphs of those, you would notice that this one, because of the 2 in front of the x squared, makes it steeper. So it'd be, if it were x squared, it'd be more gradual like this. And again, the plus 2x, that's going to move things up and down. So in this case, it moves it down, and it moves it over to the left a little bit. This one, again, notice it looks a lot like the u of y equals x squared. But here, the 2x squared makes it steeper. And then the 4x here, again, moves it down and left, or left and down, rather. And again here, another one. Just examples that I want you to notice. The thing that we're most concerned about these, though, is what are called the zeros. It's where it crosses the x-axis. Sometimes it crosses the x-axis, sometimes it doesn't. So just to review for us, quadratic equations is nothing more than a quadratic function set to 0. Again, a cannot be 0, otherwise it's a straight line. Examples I just showed you in the last one. And our concern is going to be where this equation crosses the x-axis. We're looking for the zeros. So there we go, it's official. Roots or zeros of the equation, that's the x-intercepts, or the x-intercept, there's only one, of the graph of a quadratic equation. So our example here says one way to solve a quadratic equation is to graph the related quadratic function, which we've been talking about. The solution of the equation are the x-intercepts of the related function, again, or the roots of the zeros. So if I graph this one, x squared minus 4, notice it looks a lot like x squared, except that it moves straight down by 4, okay? And its zeros right here, that's where it crosses the x-axis. And that's what we're going to spend most of our time concerned with. In this case, we can see those points are 2, 0, and negative 2, 0 in this case, if I were to graph this. This is the only section, by the way, we're going to spend time graphing these. Mostly we're going to use we have a much nicer way in order to find those zeros, but I'll show you that later. So our first actual example, again, x squared minus 1 rather equals 0. Now, as far as you're concerned right now, graphing these, just going to do a little plug and chug stuff. So you plug in a 0 for x here and get 0 minus 1 equals 0, right? I'm sorry, you're looking for where it equals 0. That's what I'm trying to spit out. You're going to graph x squared minus 1, so y equals that. And you plug in some numbers. So you'll plug in a 0, right? So y equals 0 minus 1, so y equals negative 1. So you graph the point 0, negative 1, which is actually down there. And then you can put in some other stuff. Plug in a 1. So you'll plug in y equals 1 squared minus 1. Y equals, well, 1 squared is 1 minus 1. Y equals 0. So you'll plot the point 1, 0. Oddly enough, that happens to be the 0. It's right there. And again, if I use my arrow so it's easier to see, it's right there. And then you would plug in, try a -1. And that's we've been practicing this sort of thing, right? So y equals -1 squared minus 1. Y equals then, well, -1 squared is 1, minus 1, it's still 0. So you would plot the point, we can see it right there, -1, 0. And so you look, so this is the graph of it, and where does it cross the x-axis? Well, it crosses at 1 and -1. So those are the two solutions we're looking for. Now sometimes you'll see here we have x squared equals 0, right? So again, you're really just going to graph x squared, and that's that parent function we talked about. So you plug in a 0, right? 0, 0. You plug in a 1, you get 1, 1. You plug in a 2, you get 2, 4. Plug in a -2, you get -2, 4. Plug in a 3, you get 3, 9, right? Plug in a -3, you get -3, 9. So it creates this graph. Your concern is, again, where that 0 is. Where does it hit 0 on x? And one more here. This one, x squared plus 1 equals 0. We can see from the graph here we're going to have no solutions. It does not cross the x-axis anywhere. And again, you plug in a 0 here, right? So you get 0 plus 1, and so let's just do that rather than talking about it. So again, y equals x squared plus 1, so y equals 0 plus 1, so y equals 1. So my point 0, 1 happens clear up here, and that means it's not going to cross the x-axis anywhere. So when you graph and you look for the zeros, right, or those roots, there are none. Nothing works. Okay, so we're going to start with the first example here, x squared minus 16. So again, what you're going to do is you're plugging in, right? You're going to say y equals x squared minus 16 and work out the math. So you're going to plug in here -5. I'm starting picking some numbers here, but I kind of know that 4 is going to work because I looked over at this 16. So, but again, you take a look here and you plug it in. So you have y equals -5 squared minus 16, which by the way is 9. And you plug each of these in. You find that -4 and 4 both create 0. And we can see that when you go ahead and you graph it, those points right there. I'll give you a second to take a look. Again, it's not a big deal. You plug in 0, right? And you're going to generate a 16. So that's that point down here. You plug in a 1, a -1, rather than you get -15 rather. And you plug in a 1 and you get -15. And it's that nice gradual curve along the way that you graph. But again, we're not spending a lot of time on this part. Just kind of an example of it. What we're concerned about, though, are these zeros up here. Where does it cross the x-axis? Okay, so on the second example here, we can see that we have, again, 3x squared plus 6 equals 0, so we're looking for those zeros, and that really means y equals 3x squared plus 6. Now, by the way, as long as the coefficient here in front of the x squared is positive, this thing's going to go up. Okay, so just make sure we understand that part there too. So one of the things I recommend is plugging a 0 in first. If you do that in this case, you're going to find that y is 6. So there's the point 0, 6. If that very bottom of this thing, right, is above the x-axis completely, none of this line is ever going to cross the x-axis. So it's no solution. You can plug in that you want to and try it, but no matter what, you're going to find that everything's going to land above. If you plug in a 1, right, you're going to get 9. A -1, you're going to get 9. So you can see this thing's just going to continue to climb the entire way. So those are no solutions. And again, we're going to talk about an arithmetic way for solving these later on. And then the last one, or the last example, again, as I said, try plugging in a 0 first. Before you do that, though, this one is not in standard form. So we have x squared minus 25 equals -25. Go ahead and add that 25 to both sides. And you're going to get x squared equals 0. So again, we're looking at graphing y equals x squared. And you plug in that 0 to begin with, so y equals 0 squared, so y equals 0. So you do get the point 0, 0. And since we know that these only continue to climb, nothing else is going to work. You can plug it in if you want to. You can plug in and get 1, 1, right? -1, 1, and so on and so forth. Plug in 2 and you get 4, -2, 4. So there is only one solution this time. It only hits the y-axis in one spot and you're done. and that point is 0, 0, so our 0 is 0, or our root is 0. So, as mentioned, there is certainly a more arithmetic way to solve these. Here's the idea. X squared, let's say x squared is k, right, some number. We can find the square root of x, or find the answer for x, rather, by taking the square root of k. For instance, if x squared equals 81, right, I take square root of both sides, and we find it's plus and minus 9. The reason we say plus and minus 9, I don't want you to forget that 9 squared is 81, but negative 9 squared is also 81. So it's with two answers for that, right? So what is the solution of this? Well, the way to solve that is we're going to basically solve for x. So we have 3x squared minus 75 equals 0. Subtract that 75 from both sides. Divide off the 3. And we find that x squared is 25. Now this only works, by the way, when you're down to x squared and it's a perfect square on the other side. This one comes out nicely, I mean, if you were to graph it. And it doesn't have to. I mean, you can take this square root, get those irrational numbers. Really tough to graph if I ask you to do that. But obviously, again, x squared is 5, right? Because 5 times 5 is 25. And it's also negative 5, because negative 5 times negative 5 is also 25. So in the first one, A, we have m squared minus 36 equals 0. So add that 36 to both sides, and m squared equals 36. The square root of both sides, right? So m is both the positive and negative square root of 36, or m is plus and minus 6. So the answer again is 6 and negative 6, which you're looking for. So if you were to graph this, you would find that 6 and negative 6 are the zeros, or the roots. Alrighty, so in this one, same kind of thing. We're solving for x squared, just like we'd solve with regular linear equations. So 3x squared plus 15 equals 0. Subtract that 15 from both sides. 3x squared equals negative 15. Divide off the 3. X squared equals negative 5. Now here's the thing. This one has no real solutions. You can't say it's plus and minus square root of 5, because there is no way to, again, with real numbers, there is no way to get the square root of a negative number. Plug in your calculator, you get an error, that sort of thing. Now when we get to imaginary numbers, yes, there is that possibility, because technically I squared is the square root of negative 1, but we're not ready for that yet, so don't sweat that piece. We would just currently say there is no solution with real numbers. Then our third one, 4d squared plus 16 equals 16. So we subtract that 16 off, and we get 4d squared equals 0. Divide off the 4. D squared still equals 0. Now the square root of 0 is 0, so when I take the square root of d squared, and the square root of 0, d is 0. Now you can say plus or minus 0, that makes no sense, so it is just 0. One solution in this case, meaning if you graphed it, it would obviously just touch the x-axis there. Okay, so on this one, again, story problem fun here, right? An aquarium is designing a new exhibit to showcase tropical fish. The exhibit will include a tank that is a rectangular prism, so nice pretty picture there, with the length is twice the width. The volume of the tank is 420 feet cubed. What is the width of the tank to the nearest tenth of a foot? So by the way, we do know from the picture here that it is going to be 3 feet high. It's the length and width that we are currently going to be most concerned about. So we know volume is length times width times height. The volume is 420, as was stated up here. So the 2 times the width is the length there, right? Then the width, and then times the 3. So again, length, width, and height. Combine like terms here. So w squared, and then 3 times 2 is 6, so it becomes 6w squared. Sorry, it's not technically combined like terms, we are just multiplying. Then divide off that 6, so we get 70 equals w squared. So the width is the square root of 70. Now the thing is, we have plus and minus here. Yet that doesn't make sense to have a minus, because you can have a minus width. So it is going to be just the plus in this case of about 8.4 feet. Okay, we're using the tank from the last question here. This time we're saying that the height is now 4, not 3. But everything else can remain the same. Oh, except, I'm sorry, the volume is instead 500 feet cubed. So, again, volume is length, width, height. We said the volume in this case is 500. We know that the length is twice the width, so we're going to say 2w times w, and then the new height of 4. So 500 equals 8w squared. Divide off that 8, and w squared is 62.5. Then again, taking the square root of both sides, so w is the positive and negative, technically, square roots of that, so 7.9 approximately, because it's like 7.90 blah blah blah, right, goes on. But again, so we're talking about a distance, so it can't be negative, so w is about 7.9 feet. Part B, what are the disadvantages of using a graph to approximate the solution? Well, the disadvantage would be that if it's going to be something like this, where you're taking the square root of a non-perfect square, there's no way you're going to graph that right. You're not a computer, so you're going to definitely be off. You're going to have some issues there when it comes to irrational numbers.